Everybody. So, coming to the design concepts of building services. So, in first model we have discussed in detail about water supply, drainage and solid waste management. Okay. So, in that unit or in that model we have discussed in detail about how the water supply schemes are going to execute in industry as well as in domestic, okay, as well as in residential related issues we have discussed in detail. Then what are all the basic water conveyance are there in residential building, then how the different types of traps, different types of taps using, and what are all the different types of drainage systems we are adopting. Okay. So, that part we have discussed in detail. Then in continuation with that we have discussed in detail about the principles of drainage systems, okay, then different shapes and sizes of drains as well as sewers, that part we have discussed in detail. Okay. Then the methods of laying the sewers, that part we have discussed in detail. Then the last bit of this first model, that is the solid waste management. So, what is solid waste management we have discussed, and then what are the different collection processes are there, okay, how the solid wastes are going to collect, that part we have discussed in detail. Okay. So, that is related to first model. So, coming to the second model, that is model 2 in building services, that is design concepts of building services. It is completely related to heat, ventilation and air conditioning. Okay. So, coming to the second model, right. So, model 2 says about, in short form we can call it as a HVAC system, that is heat, ventilation and air conditioning. Okay. So, in short we can call it as HVAC system or HVAC system, that is heat, ventilation and air conditioning. Okay. So, of course, as we comparing to the model 1 and model 2, model 1 is completely related to the water supply related issues. Okay. We are going to discuss about water supply and its drainage, then how the waste is get disposal, okay, how the treatments, that is disposal of waste or solid waste, that part we have discussed. Okay. So, coming to the model 2, it is completely related to the energy of the building, that is how the energy level is of the building is going to vary with respect to the thermal resistivity or in thermal insulation process, how the building behaves. Okay. So, what are the reasons how the propagation of heat get liberates. Okay. That part we are going to discuss in detail in the second model. Okay. So, coming to the syllabus, of course, it says about model 2 behavior of heat propagation, right, how the heat gets propagates, okay, that behavior we are going to discuss. Then the thermal insulating materials and their coefficients of thermal conductivity. Okay. So, the thermal conductivity for the different materials is vary from different, okay, that is it depends upon the nature of material, their conductivity against thermal, that is the heat get transferred from solid to solid member. In some cases even within the liquid the heat is get transferred, even in air also heat is get transfers. Okay. So, that portion we can call it as usually conduction, convection and radiation. Okay. So, that part we are going to discuss in detail. Then the general methods of thermal insulations, what are all the basic methods are there in thermal insulation technique, okay, and thermal insulation of roofs, exposed walls. Okay. So, for example, the roof is completely exposed to atmosphere, okay, throughout 365 days it in turn exposed to atmosphere. Of course, during sun, okay, especially from 11 to 4 there is a peak hour, okay, I can say. Okay. So, during that time, so the heat liberation process or the conduction process, that is heat is transferred from top layer to the bottom layer of RCC slab is maximum in that situation. Okay. So, how to give the in thermal insulation process for the roofs as well as for walls. Okay. So, that part we are going to discuss in detail. Then that is related to the heat ventilation process, okay, I mean the thermal part. Then the next part is ventilation. Okay. In that we need to concentrate the definition, that is introduction of ventilations. Okay. Then the necessity of ventilation. Okay. So, why we need the ventilation process, it may be of artificial ventilations or natural ventilations, depends upon the building, the type of building. Then the system of ventilations we are going to discuss in detail. Then the principles of air conditioning, okay, how the air conditioning techniques are going to adopt for the present scenario, right. So, that part we are going to discuss. Then air cooling, okay, that technique, then different systems of ducting and distribution. Okay, so ducting, usually we in shopping malls or in cinema theaters we are going to do some ducts. Okay, through that your air is going to be entrapped. Okay, so how to remove the used air and how to replace it by fresh air. Okay, for that we need a ducting process. Okay, so how the ducting are going to be executed in buildings, as well as it might be of commercial or it might be of residential, I guess. Okay, that part we are going to discuss, how the distribution of fresh air takes place. Okay. Then the essentials of air conditioning systems. So what are the basic requirements of air conditioning? Okay, so this is regarding syllabus. Okay, so the entire part we are going to discuss one by one in our upcoming classes. Okay, so in that the first one is behavior of heat propagation, right? So in that the first topic we are going to concentrate today is behavior of heat propagation. Okay, so in that the concept is quite simple, how the behavior, how it behaves once the heat is get liberates from a solid members, or it might be from the liquid, or it might be from the air. Okay, usually we have come across in our day to day activities. Okay, if I will take one steel rod, right, if one end is going to be heat, of course automatically if other end is also get the effect of that heat. Okay, heat is get transferred from one end to other end, right. So this process we can call it as a conduction process. Okay, so there are only three chances if if you want to experience that heat. So heat liberations or heat transfer is going to take place in three conditions. One is the conduction process. Okay, the conduction process is nothing but if the heat is transferred from solid members. For example, if I hold a wooden rods, so one end is get heated, of course it in turn transfer. Of course, in terms of wood, its thermal resistivity of that heat in wood is good comparing to the steel or iron. Yes or no? Because in steel and iron, of course, thermal conductivity differs from materials to materials. Even glass is of different thermal coefficient, wood is different, bricks are different, stone is different. Okay, similarly iron, do have different alloy systems. Okay, so every material has their own conductivity against heat. Okay, so some materials fastly they will transfer the heat from one point to another point. In some materials they will in turn minimize the heat transfer from one point to another point. Okay, so in that heat propagation, how it behaves, right? So heat transfer is a discipline of thermal engineering that concern the generation, use, conversion and exchange of thermal energy. Of course, so the behavior, the main motto behind the behavior or the study of heat propagation, how the heat is get liberates. Okay, so that's nothing but it is the continuous, it's a process of generation, how the heat get generates. Then use, in some cases of course we need to use that heat. Yes or no? Of course, there are purposefully we are going to transfer heat from one point to another point, so that we need to do something by using that thermal energy. Okay, that's also use. And then conversion, in some cases we need to convert that to other different sources of energies. Okay, so heat is in turn transferred to other mode of energies, because I need to use it and I need to reproduce it some other product by using that heat. Okay, for that cases also we are going to use that heat concept or heat energy concept. And the exchange of thermal energy, yes, in some cases we need to exchange that thermal energy into some other energies. Okay, for example, for boiling purpose we need of course heat. Okay, purposefully we are in turn transferring heat. Yes, so we are going to have a pan. Yes, if you want to boil, because I need hot water. Yes or no? So that indicates what? Even though the pan is going to be heat at first, then the pan will in turn transfer the heat to the water. The water gets boils. Okay, so that is the transfer or exchange of energy for the different sources. Depends upon the requirement, the transfer process takes place. Then the second point is heat transfer is classified into various mechanisms such as thermal conductions, thermal convection and thermal radiations. Okay, so heat is going to transfer only by using these three medias. Okay, either by using the conduction process, that is thermal conduction, that is heat transfer due to in solid members. Okay, due to solids, if in the solids if the heat is get transferred, it's completely related to thermal conductivity or thermal conduction. Then the thermal convection is nothing but the transfer of heat from liquid members or liquid particles. Okay, so liquid molecules will in turn liberate the heat and it will in turn transfer the heat. Okay, that is thermal convection. Okay, then the radiation is nothing but transfer of heat through gases or air. Okay. Yes, of course, these three parts we have already experienced in our day-to-day activities. Okay. Then the third point is engineers also consider the transfer of mass of different chemical species either cold or hot to achieve heat transfer. Of course, in some cases we purposefully transfer the heat from one point to another point. Okay. In some cases we need to minimize the heat by transferring the cold or cool air. Yes, sir. For example, your fan will enter. What's the use of fan? Of course, because the atmosphere is little bit hot in nature, right? So it's not in a comfort zone. We are not in a comfort zone. So automatically we are going to switch on the fans, or we'll use some artificial ventilation process that is called air conditioning or air cooler. Yes, sir. So that will in turn give you the fresh air, so that the atmospheric temperature will be going to minimize. In the same case, if we consider some cold regions, in there we need to maximize the heat, because the heat inside the building or inside the premises is said to be minimum. For example, in a single digit, 5 degree, 4 degree, even in some cases it might be of 0 degree. So it's not comfortable for a human beings to work in that particular place. So in that cases, we need to transfer the heat from external agency. So we are going to prefer a heaters, so that the hot air will in turn transfer to that building or building component, so that it must give you some comfort zone to a person who is working in that premises. Yes or no? So that is called engineering system. Okay, transfer of heat or transfer of cold from one place to another place. Okay. Then heat conduction, also called diffusion, right? It's the direct microscopic exchange of kinetic energy of particles through the boundary between two systems. Yes, of course, if I take material, you can take any material. For example, if I say if this end is going to heat, okay, if I am going to give a heat to this end, if I touch this one more end, definitely the heat is get transferred from the solid members because of the intermolecular arrangements within the solid. Okay, so the transfer of heat takes place. Okay, so depends upon the thermal conductivity of that material, how it in turn refuse or give that reaction against that heat transfer, that in turn differs from materials to materials. Wood will in turn minimize the heat transfer. Okay, even steel will give a rapid transfer of heat. Yes, sir, that depends upon the thermal conductivity of different materials. Okay, so this is regarding the behavior of heat get propagates. Okay, then the second point is thermal insulating materials, right? Second point in the HVAC system is thermal insulating materials. Thermal insulating materials, of course, and their coefficients, right? So thermal insulating materials. Now we have discussed about the behavior of heat get liberates. Okay, so now we need to concentrate about the thermal insulating materials. We need to insulate, because in every stages heat transfer, because in some situations, for example, if you are working in a room, okay, let us say you are working in an office. Okay, so if one person is working, so in that room, of course, you are at a comfort zone. Okay, without any other alternative arrangement to minimize or maximize the heat, I can say. Okay, so if the office itself is filled with around 10 persons, okay, or 10 laborers or workers, then automatically the heat liberates in that office or in that room or in that working area is going to liberate. Yes, or because of all these three: conduction, convection and radiations. Okay, heat may even transfer from persons to person. Okay, so due to the respiratory process, even the air is going to get little bit hot in nature. Yes, sir. So these aspects will in turn maximize the thermal or the temperature variations within that working area. That's why we require your ceiling fans or table fans or air conditionings or air coolers in a working area, that too comprising of more number of workers. Okay, so because we are going to concentrate on insulating materials, we need to minimize. So because in all the cases we should not supposed to directly depends on the equipments, because of course to run the to run the fan as well as air coolers or air conditioning systems, of course we need some other alternative energy, that is electrical energy, no doubt. Is there any chances to adopt a principle, that is the working principle behind the construction of a building, which will in turn use some insulating materials so that I can minimize the thermal propagation or the heat propagation process. Yes, there are so many materials are there. Okay, there is huge material requirement is there in present scenario that available in market, right? That is different types of insulators. That is the insulating materials, right? So in that, of course, as we know, usually in summer we prefer the of course the normal temperature itself is going to rise around 30, 35, 30, 40 degrees centigrade. Yes or no? So in that cases, definitely we need to go to some other alternative arrangements. Yes or no? So if we adopt a situation, that is, if you adopt a construction technology or construction techniques, so that by adopting these techniques, there is a chances of transfer of heat from outside to inside is minimum. Yes or no? For example, of course, the walls, especially walls and roofs. Okay, these two are the main components. The heat is get propagates in the building. Okay, especially it might be of residential or it might be of institutional buildings. Okay, even in industrial buildings also, of course, the external heat is get transferred to inside. But even though, apart from that, even the internal arrangements, for example, some machines are running, let us say, okay, even they are also going to liberate the heats because of that kinetic energy. Okay, so movement of vehicles or movement of the motors or movement of any particular equipment will in turn liberates the heat inside the buildings. That also gives some uncomfort to workers or public who is working in that premises. Okay, so we need to go to other alternative resources, but nowadays, of course, alternative resources are minimum. That's why we should not supposed to go ahead with these utilization of resources. So is there any chances to minimize the transfer of heat from external to internal? For that purpose, we need to use some insulating materials, right? For example, your plywoods, then thermocol sheets, okay, asbestos sheets, okay, crayons. The other byproducts are there. Okay, depends upon the cost, depends upon the type of building, depends upon the budget available. So depends on these considerations, we can decide the insulating materials. Okay, if the budget is minimum or if the work is minor, so we can prefer minimum insulating materials. So cost effective. That cost is also one of the major criteria to decide the in implementation of other techniques. Okay, so this is regarding thermal insulating materials. So these materials are nowadays available in market, right? Thermal insulating materials are used to reduce the flow of heat between hot and cold regions. Yes, of course. Then the sheeting often placed around steam and hot water pipes, for instance, reduce the sheet loss due to the surroundings, and insulation placed in the walls of refrigerator reduce the heat flow into the unit and permits it to stay cold. That indicates, so even in refrigerator also, right, if we observe the inside portion of a refrigerator, of course it feels cool, but once we go to the back portion of that refrigerator, of course the motors are running over there, okay, and that entire place seems to be little bit hot in nature, because so it will in turn liberates, it will in turn transfer the normal air to little bit cold air, that will in turn pass through the object. Yes or no? By transferring that entire heat is get transferred from that point to the innermost part, okay, in a insulating manner. Okay, so in between we are going to use some sheeting materials so that it will make the inner portion of the refrigerator cool, whereas the outer exterior part is said to be little bit hot in nature. So these are the insulating materials are available in market right now. Okay, similarly we can quote n number of examples related to the thermal insulating materials. Okay, so now we need to understand what is the thermal insulation. Yes, so what is this thermal insulation? Okay, so where there is a difference in temperature of inside of a building and outside atmosphere, heat transfer takes place from area of higher temperature to lower temperature. When the external temperature is low, the internal temperature should be high so as to produce thermal comfort. Yes, so thermal insulation indicates the conduction or provisions by way of which transmission of heat from or in the room is retarded. Thermal insulation can be attained during the design process from providing thermal insulating materials on the shell of the building, right. So the thermal insulation is nothing but, in general, we need to minimize the heat transfer from external portions to internal portions. Okay, of course, the wall is the wall is exposed to atmosphere. Okay, so due to sun rays, the external portion is going to be a little bit hot in nature, right? So the temperature will of course going to rise. Okay, similarly, this is a solid member. Okay, it will in turn transfer the heat from this external agency to the internal portion. Okay, from this external to internal, it will in turn transfer the heat due to conduction process, thermal conduction. Okay, so the internal portion, of course, here we have experienced 35 degrees centigrade as an example. Okay, of course, the innermost part, it may not exactly equals to 35 degrees centigrade, I can say, but it might be little less than that, but it should be little bit more than that of what is exactly available in atmosphere, I mean in room. Okay, for example, standard temperature, the standard room temperature is around 27-28 degrees centigrade due to the heavy sun raises. Okay, so the temperature rises may takes place up to 30-35 degrees centigrade. Then of course that definitely it seems to be a little bit hot in nature. So we are at an uncomfortable zone. Yes or no? So for that we need to prefer the insulating materials on this wall. Not exactly at its external portions, in internal portions. Yes, sir. If this is internal portion, okay, external portion is on either side. Okay, so we need to adopt this thermal insulating materials on this internal portion, so that the heat transfer from that external agency to this internal wall is going to be minimum. Because these are the thermal insulating materials I have adopted. For wall, it might be of plywood sheet, it might be of thermocols. Usually in shopping malls, if in some cinema theaters we can prefer. Okay, we can come to know that of course there are some insulating materials they are adopted. Okay, so that is that process we can call it as thermal insulation process. Okay, so next one is the general methods of thermal insulations. Okay, so the next part is methods of thermal insulation. Methods of insulations or thermal insulations. Okay, so basically we have three methods. Okay, so the first one, heat insulation by orientation. Heat insulation by orientation, and the second one is heat insulation by shading, and the third method is heat insulation by proper height of ceiling. Okay, so these three are the basic methods of thermal insulations. Okay, so now we'll discuss one by one. Okay, so the first one is heat insulation by orientation. See, we can observe here there are basic three divisions are there. One is orientation by providing shadings, and by adopting the proper height of the buildings or height of the ceilings. Okay, so first one is orientation. Of course, as we know, usually we come across the orientation technique. Okay, once we prefer the main door should be towards the north or towards the east, automatically, of course, if I prefer a main doors of the residential building is towards east. Okay, so automatically at morning, because of sunrise, so the rays are directly get entered into the house if we don't have any obstacles. Okay, automatically the heat liberations inside of the building seems to be a little bit high in nature. Yes or no? If we prefer some north facing residential building, let us see an example. Automatically the easternmost part of the wall is going to experience the maximum heat. Yes or no? Because the heat is get transferred from one body to another body. Yes or no? So it requires some time. Yes or no? If this external body or external wall is in contact with the sun, right? Of course, the heat is get transferred to this room. So this wall is comparatively experience the minimum heat, because this external part is not at all exposed to the sun as the right side portion of the wall is experiencing. So that's the difference between the orientation of the buildings as well as building components we are going to adopt. Okay, usually for example, if I prefer, say with respect to the means plinth level, right? So this is what the orientation I can say. Okay, so this is the starting point of sunrise I can say. Let us say an example. Okay, so at morning usually this is what the angle of inclination, so we can easily calculate 0 to 90 degree. Okay, similarly 90 to 180 degree. Okay, so if I prefer, if the sun is at 10 degree centigrade with respect to your building level, plinth level, horizontal level, okay, so then the heat rays getting enter into the house is minimum, of course. That's why we should not supposed to experience more at the morning stages. Okay, so exactly at 11th, or I mean at 11 hours, or 11 a.m. to around 3 a.m. I'm sorry 3 p.m. Okay, 11 to 3, the heat liberation process seems to be little bit high throughout the entire one day, 24 hours. Of course, usually we can experience sun from morning 7 to evening 6, 5, depends upon the region. Okay, so during that 12 hours probably, okay, 7 to 7 we can say. Okay, so the maximum heat we can experience is around 11 a.m. to 3 or maximum 4, depends upon once again the region. On an average we can take 11 to 3 p.m. will be the duration, so that we can experience more effect of sun. Okay, so in that particular duration, okay, so what should be the angle of inclination we need to make towards the component of the buildings? Okay, so we need to prefer the main halls or bedrooms or kitchen areas or whatever the building components we can say. Okay, it may be related to residential or it may be related to institutional. Okay, so we need to, by orienting the building itself, we can in turn minimize the heat get liberates, right? So in that internal building surfaces which can receive direct incident solar radiations from winter to summer, the orientation of the building with respect to the sun has a very important bearing on its thermal behavior. For optimum orientation, there are usually conflicting requirements. So minimum transfer of solar heat desired during the day in summer, while maximum heating of a room by solar heat is required during winter. Yes, the optimum inclination, of course. So by using optimum angle of inclination of different facings of the buildings, right? So the building orientations will also going to differ. So we need to consider the orientation of the buildings or orientation of the building components. Okay, so with respect to the sunrise, with that too with respect to the different face of buildings. If the building is south facing, then the orientation of the building components are differ. If it's a north facing, the orientation is different. If it's east facing, orientation is different. If it's west facing, orientation is different. Okay, so this process we can call heat ventilations by providing suitable orientations, right? So the second one is heat insulation by shading. So the second technique is heat ventilations by shading. So in that, shading of roof brings down the surface temperature. That indicates what? The shading is nothing but we are in turn adopting some other insulating materials. We are going to cover it. Okay, for example, if we can prefer in some cases, usually we are, if the slab is exposed to atmosphere and if we experience the maximum heat within the room, automatically in some cases they will prefer some thermocols. Yes or no? For example, some fall ceilings. Yes or no? So there are lighter materials, right? So it will in turn, whatever the surface, I mean, if for example, if you have a GI sheet roofing, okay, then the heat liberations or heat transfer is huge comparing to the RCC slab. Okay, so in that cases, below that RCC roof, by giving some suitable freeboard, they are going to fix up some asbestos sheets, okay, or some insulating materials. It might be of thermocols, it might be of your false ceiling techniques. So they are in turn minimize the transfer of heat from external agents to the internal. Even vice versa, even it's going to minimize the transfer of cold from external agency to the internal one. Okay, for both the cases, we are in turn using this shading. Shading is nothing but this is additional materials in which we are going to apply on that surfaces. Okay, especially by raising the parapet wall. right? So the main purpose behind raising parapet wall in a residential building, or not only residential, you can take any buildings, okay, it might be institutional, organizational buildings, okay, public buildings, we are in turn raising the parapet wall, because the heat transfer towards the slab is going to be minimized by raising the parapet wall. So the parapet wall surface will in turn take care of that heat. So automatically the slab is going to experience minimum heat comparing to the parapet wall. So that's also, so by raising the parapet wall is also one of the best method of giving shading to heat thermal or heat insulation technique. Okay. And the third one is heat insulation by proper height of ceiling. Heat insulation by proper height of ceiling. Usually we can experience some industrial buildings. Okay, some industrial buildings, automatically the ceiling height, floor to ceiling height seems to be more than that of residential one. Yes sir, in residential usually we will prefer 3.1 meter or 3 meter probably, okay, 10 feet in a general. Okay, similarly if I prefer a warehouses or some small scale industries or large scale industries, okay, some power plants, okay, especially industries related issues, automatically we are going to maximize the heat, height. That is from floor to ceiling height is around 4 meter, 4.5 meter in some cases, even they will reach up to 5 meter. Yes or no? So that's because of heat insulation process. That's one of the best technique of insulating the heats or minimizing the heat get liberates. Okay. So usually the height, yes, you can observe this point. The effect of vertical gradient of radiation intensity is not significant beyond 1 to 3 meter. Okay. So why we are going to, for example, if how the building height is taken it as 3.1 meter or 3 meter generally. Okay. So a person's height, on an average the person height is of 1.5 meter, let us say. Okay, on an average 1.5 meter. Okay. So on above, if you prefer 1.5 meter, okay, then the building height is said to be 3 meter now. Yes or no? So because that 1.5 meter, because if we go below 1 meter or 1 to 3 meter height of the building, height automatically the heat get liberates in that entire room is seems to be little bit high in nature. That's why we need to prefer 3 meter or minimum 10 feet as a floor to ceiling height. In some cases we have minimized the height of the ceiling, so we can experience the heat is going to transfer within that location because of the radiation. So because of the minimum height, okay, so the radiation process seems to be little bit more in that building. That's why we can experience more, the building or that room is little bit hot in nature. Okay, it's like nothing but a hot chamber. Okay, we can experience that kind of situations. Okay, that's why we need to maintain minimum of 3.1 meter as a building height. Okay, so hence it should be adequate to provide ceiling at a height of about 1 to 1.3 meter above the occupant. Okay, if occupant is of 1.5 meter plus 1.1 to 1.3 meter above, preferably we can say 1.5 meter. So 1.5 plus 1.5, it will become 3 meter will be the height of the building. Okay, that's what the process behind heat insulation by preferring the proper height of the ceiling. Okay.